Hey, yes, good day folks. Welcome to another session of Manni Talks. You must have guessed what is the topic for today. UART?
UART what?
Universal Asynchronous Receiver Transmitter. We have the I2C and the SPI, or also known as SPI. Now, what on earth is this? Yeah, all of our modules actually need communication interfaces. Starting from our radio modules, invariably the UART to communicate with the radio module from the host controller, and most of our sensors, which we have on here, are accessed via I2C, or alternatively also the SPI, the SPI interface. Now, what is all of this about? Let's have a look. We'll analyze this a little bit more in detail. Okay, what is a UART about? UART is always a point-to-point or two devices that you communicate with, and in this case we have the TX line connected to the RX and the TX from that side to RX on this side. You could also make use of the CTS-RTS line, the handshaking lines, especially recommended for higher data rates. Right, what happens with I2C? Here we have the host controller and a number of slaves, but only two lines, the clock line and the data line. But important here, the data line would send an address to the respective slave we want to talk to, and the whole system is synchronized via the clock line. Right, data exchange based on the addressing of the slaves. Let's have a look at the SPI. Okay, for the SPI, we actually make use of four lines at least. The clock line, once again, connecting all the slaves, but we have two lines for the data, the master in slave out or the master out slave in. Two lines to exchange the data, and then interesting in this case, we have one chip select or select line for each of the slave devices. So depending on the number of slaves, we would have the respective number of chip select lines. This is a very fast and efficient method of communicating to our peripherals. Okay, let's actually connect our logic analyzer and actually see what is happening on these UART and I2C lines on our feather wing with the radio module and all of the sensors. Right, now let's look at our logic analyzer. I'm actually going to start a capture here, and wonderful, you can see some data has been picked up by the analyzer. I'm going to zoom in a little bit, and we see the first two lines are the I2C, then two lines for the transmitter and two lines for the receiver of the thiony on the opposite end. Let's stop this and have a look in more detail. Let's take any of these captures. And the first line, the first two lines are our I2C capturing the accelerometer. You'll see the top line is actually the clock, and the line underneath that is our data line. You'll see that in this line we are capturing the X, Y and Z data. Let's change this to hexadecimal, and the address for the X, you can see here is 28. We captured 2 bytes, and for the 2A, which is the Y with 2 bytes, and 2C being the Z axis. Right, we captured the X, Y and Z axis, and the processor converts this to a value to be transmitted via our radio module, and here you can see the transmission signal of our radio signal, and let's see what's happening here. I can see the 06 here obviously is our send broadcast message, which sends the data to our radio module, and contained in here, let's switch that to ASCII, the X value contained in there, there's the Y value, and here we have the Z value. As this package goes out, we actually get a confirm back from the radio module which actually tells me that the broadcast has been completed, which is the 44, with a checksum, the 47, and shortly after it sends a second message, transmission completed, which is the C4, with a length 2 bytes and 1 byte the status, and the checksum right at the end, C7. Right, in the meantime, our receiving module has received the data package on the TX and RX lines, which I've captured at the bottom here, and theoretically this capture should be the same as I've sent across previously. Now let's have a look at this guy here, and if I display that in ASCII, I see that my X package has been received. This is the command 84, X value, the Y value, and the Z value. All of this in a time span of about 10 milliseconds. You can see the whole capture from here to there. Right, folks, that's it. Our little data capture of the I2C being transmitted and being received on our receiving module. Right, folks, that was our little demonstration on the UART I2C Inspire. Yeah, now it's up to you to play around and test. I wish you all of the best. Till next time, keep well.
Visit us at we-online.com/WCS.